Hey, Michael, sorry it is so late that I'm sending this to you. I just now got around to recording something. I figured I would just record it instead of looking at videos just to make sure you know exactly how to do it. So this is the review we went over today in class. So I'm gonna go over some of the questions with you and hopefully that helps make some sense. So on Monday or Tuesday, we talked about triangles. You should kind of remember this from sixth grade. Triangles all add up to 180 degrees. So when I look at a triangle like this, we know that whenever I have a triangle, first of all, if I see an X, you have to set up an equation. You can't do anything, you can't solve, you can't circle an answer until that equation is set up and you have solved for X. So in this case, since it's a triangle and they gave you all three angles, you just have to set them all up equal to each, or add them all up and set it equal to 180. So if I look at angle R is 2x plus 6 plus, if I look at angle S, that is x plus 16. And then if I add angle T, that is 2x minus 2. And all of that adds up to 180 degrees because it's a triangle. So then I would simplify everything I can, like combine like terms. So I have a 2x plus an x plus another 2x. So that gives me a total of 2 plus, technically that's a 1x, so 3 and then 4, 5 x's. And then I do the same thing with my numbers. I have a positive 6 plus 16, which is 22. And then minus 2 would bring me back down to 20, and that would be a positive 20. And I bring down the 180 because if you think about drawing your line, that's on the right-hand side. I haven't done anything with it, so I just drop it down. Now this is a lot more manageable in order to solve. So just like you would do any equation, minus 20 on both sides. And that would give me 5x equals 160. And then I would divide by 5. And I don't have my calculator on me, so I'm gonna have to do it. Long division, 5, that goes in what, 3, 2. So I get x equals, oh my goodness, x equals 32. Now it's asking for the angle RST. So be careful, because if this was a multiple choice question, I guarantee 32 would be an answer. But up here, it's asking for angle RTS. So I want to start at R, go over to T, and then over to S. And the angle that's highlighted is this one here. So I'm now going to take my answer that I got and just plug it in for X. So I had 2x minus 2. So I'm going to replace X with what I got and then solve it. So 2 times 32 is 64 minus 2, which gives me 62 degrees. So this one, I know my students on Tuesday did pretty well on. They didn't seem to have too many issues. So I'm pretty sure that you probably got that part pretty well. So then we went on and talked about exterior angles. We discussed on Monday or Tuesday, I showed like a thing where we moved around angles, and I believe Ms. Clark should have done that, but if your sound wasn't working, you may not have gotten all of that. But what it says is, in order to find missing angles, or I'm sorry, in order to find the exterior angle, which means it's on the outside of my shape, I have to take my two remote interior angles and I have to add them up. Now, the word remote here basically just says the two angles that do not touch my exterior. So when I look at my triangle here, the only two angles that does not touch angle D would be C and A. So that is what remote means. What are the two angles that are across or do not touch my exterior angle? And notice C and A are both interior, so that works. So in order to solve this, I would take my remote interior plus my other remote interior, and that's going to equal my exterior angle. So in this case, I would take angle A plus angle C if I'm looking at these letters here, not the capitals, and that would equal angle D, which would be my exterior. So if we look here and I want to solve, now the first thing I see is I have X's, or in this case Y's, but I have variables. So immediately that means I have to set up an equation. Again, variables have to have an equation. So this is my exterior angle. So in order to find exterior, anytime I'm given that, remember, it's always my remote interior plus my remote interior, and that's going to give me my exterior. So remote interior would be the two angles inside across from my exterior, which is 146. So I'm going to take 5y plus 3 and add it to my other interior, which is 4y plus 8. And that's going to be equal to my exterior, which is 146. Same as before, I would combine like terms. I've got a 5y and a 4y, which give me 9y. And then I've got 3 plus 8, which gives me 11. And then I bring down 146. And then solve like normal. So I would start by subtracting 11 and then rewrite it. And I get a 9y equals 135. And when I divide by 9, again, I do not have my calculator, so I have to do it long way. I get 15, so y equals 15. Again, if this were a multiple choice problem, 15 would be an answer choice. However, if I go back up to my question, it wanted me to solve for angle BAC. So I'm gonna start at B, I'm gonna go to A, and then I'm gonna go to C. So the angle that's highlighted is this one here, which is this here. So I'm gonna take what I got for X, or in this case Y, and I'm gonna plug it in for that. So I'm gonna take 5, and then I got 15 plus 3, 5 plus or times 15 is 75 plus 3. So that angle is 78 degrees. So again, the biggest thing to remember on here is this right here. Remote interior plus remote interior equals my exterior angle. And remote are the two angles that don't touch my exterior. And then we talked about keywords. Vertical angles are two angles that are opposite of each other. They only share a vertex. So if I look at my picture, right here in the center is my vertex. So 2 and 4 are vertical angles because they're opposite, they're across from each other. And then I had linear pairs. Linear pairs are two angles that equal 180 degrees. And I know that because the word linear means line. in a straight line is 180 degrees. So a linear pair, 180. Another word for that is called supplementary angles. So supplementary, 180 degrees. And then I asked the question, do linear pairs have to be side by side? So if I go back here, do they have to be beside each other like 130 and 50 are? The answer is no. So if I looked up here, we could see, for example, like a linear pair would be 1 and 2. Well, we have to look now at corresponding sides. So if I looked at this little cluster of numbers as like a group and say I want to look at 2 specifically, well, I would say if I looked at this being my like line that separates top and bottom, I would say that this 2 is on the top. And then if I looked at this line as being separating left and right, I would say that this is on the top and 2 is on the right. So I want to find a corresponding side. So I'm going to do the same thing, but down at the other group of numbers. So again, if this is going to separate top and bottom, the pink separates left and right. In this group of numbers, 6 is on the top of my green, but to the right of the pink, so top right. So that tells me that the 2 and the 6 are corresponding sides. Now, since they are corresponding sides, what that tells me now is that if 1 and 2 equal 180 degrees, and if 2 is corresponding with 6, that means if I took angle 1 and angle 6, because 2 and 6 corresponding, which means equal as well, that means that would also give me 180 degrees. So a linear pair not side by side, 1 and 6. I could also say angle 4 and angle 7, because 4 and 3 make a linear pair and 3 is corresponding with 7. So multiple different groupings I could come up with here. All right, and then when we see a picture like this, which is similar to the one we just looked at, these two things in this picture, so these are parallel sides. And then this one here that touches or cuts through both parallel lines is called a transversal. So that pink line is called a transversal. Anytime you see a picture similar to this, I know you're on a computer, so it's going to be helpful if you have scratch paper. I would always, always, always sketch the picture that you see and then color code. So we would color code corresponding sides. So if I looked at, again, this as a cluster, I would say, well, if I colored this orange or pink in this case, I know my vertical angle is this one because they share only that middle vertex. And then if I looked at that compared to the cluster over here, well, this one is on the top of my transversal, but on the left of my parallel. So over here on the right-hand side, I want to be on top of my transversal, but the left of my parallel. So that means these two here, this one and this one, are corresponding. So corresponding are also the same size. So all the orange ones are equal, all the green ones are equal. Now, linear pairs, which are equals 180 degrees, are formed by one of each color. So that kind of brings me back to what we just said. I know that these two together equal 180 degrees because it forms this straight line. Therefore, this green one here, for example, corresponds with that green one here. So what that does is that tells me if I took this one and this one, which are colored in different colors, they're one of each, that when I add them together, I'm going to get 180 degrees. Knowing that, we need to figure out the measure of angle D, for example, here. Now, again, I would start by color coding. So if I said this one, well, I'm going to color code the vertical angle, which is here. And then if I looked at the other set of angles, like as a little cluster, where the 48.2 is, it's below my transversal and to the right of my parallel. So I want to look below my transversal and to the right of my parallel. And then highlight the vertical angle. And then we're going to go ahead and do the others real quick. I know that this course is equal to that. I can also look at it and say, well, those are both obtuse, where the pink ones are acute. And then same thing here. So now if I want to know the measure of angle D, well, angle D is colored in pink. Well, if I look right here, that's also colored in pink, which immediately tells us that angle D is 48.2 degrees. Really no work that I had to do on this one. However, if it told you, let's see, something a little harder. Yeah, I have one coming up. So we'll look at that in a second. So if I looked at this one, again, I want to color code. So if I'm going to do this one, the vertical, and then I'm going to do the corresponding, which are going to be my acute angles, because those are the ones I colored in orange. And then I'm going to do my obtuse. Now on this one, it's a little different because I can see 42 is colored in orange, but my missing one is colored in pink. Well, if I took an orange and a pink and added them together, I would get 180. So one of each color is going to be 180. So I can set up the equation. 42 plus A is 180, and then solve. Subtract 42, subtract 42, so I get A equals 138. Pretty simple when you have just basic numbers. However, when we get to ones with X's, it becomes just a little more difficult. But if you understand the color coding, it's going to be a little simpler. So here's obtuse, vertical, obtuse, vertical. And then I'm going to do my acute ones, which kind of running together. Now, when I look at this, I know that this one that they gave me is in pink, and this one they gave me, I colored pink. Since they're the same color, I know that this pink one and this pink one have to be equal. So I'm going to set them equal to each other since they're both the same color, and I'm going to solve. So these are the same problems like you did in the first session. So I would draw my line. I would say minus 15x is here to get rid of that. Do the same thing here. And I get 2, wrong color. I get 2x, and then I'm going to bring down minus 4, equals 12. Get rid of that one. I get 2x equals 16, so therefore x equals 8. But again, always double check and ask or go back and look at what the question's asking for, because in this case, it says what are the measures of the angles. It didn't ask what x was. So since these two are both equal, I can choose whichever one I want. So if I want to plug 8 in for x on the bottom one, I would say 15x plus 12. I'm gonna change x to 8. And then solve. Still don't have my calculator. So I get 120 plus 12. So I get 130. And I can look at that and say, well, it's obtuse, so my answer of 132 is probably correct. If I look at this one really quick, again, I would start by color coding. Always color code. So I'm gonna do all my obtuse, one color, and I'm gonna do my acute in another color. All right, it says which one is not true. So A, or the first one here, says Z is 63.5. Well, Z is in pink. So if I want to figure out Z, I got to figure out what the pinks are equal. Well, if I look over here, I know that if I took this number 116.5 and that pink one together equals 180, all I have to do is figure out, well, my pink, let me just do pink plus 116.5 equals 180. And then I'm gonna subtract 116.5 from 180. And so I can solve and say my pink is equal to 63.5 if I do the math. So since pink is equal to that, Z is in pink, that's a true statement. Now, if I come back up here, stuff looks sloppy. It says angle Y and angle Z equals 180. Well, angle Y is green, angle Z is pink, and if I have one of each color, it forms a straight line, which is 180. So we're good there. Then the next one says angle Y. I'm gonna have to clean this up. I'm gonna go back and redo my colors. Okay, it says angle Y is equal to 180 minus 116. Well, if I come to angle Y, well, if I look right here, Y is in green, and I know Y is 116, so I wouldn't need to do any kind of subtraction problem. And then if I look at this last one, it says angle Z plus 116 equals 180. Well, if I took Z plus 116, well, 116 is in green, so I know that one is 116.5. If I add this plus this, does it form a straight line? And the answer is yes, so therefore that one works as well. So not true, had to be C. So it's really kind of tricky, but I think if you color code, it's going to make a lot more sense for you. Real quick, the only other one I really want to make sure to look at is this. I'm not going to solve them, but I want to make sure you just set them up correctly. So if I look at the one on the left, and this is an exit ticket I made up today. The first thing I want to do is start by color coding, just like we have been doing. So I'm going to color code my obtuse, color code my acute. And when I look at this, I can see, well, this one is in green, this one is in yellow. And again, remember, if they were both green or both yellow, they would just be equal to each other. But since they're opposite colors, I know I'm gonna take this green and this yellow, and together they equal 180. So this equation here is the one that I would need to solve. And then if I look at this one over here on to the right, it says, what's the measure of angle ACD? Well, I see x's, so I'm gonna have to set up an equation. But remember, my exterior angle is equal to the sum of my two remote or not touching opposite interior. So to solve this, I would say 3x minus 2, which is this angle A. And I would add my angle B, which is 7x minus 1. And that would give me my exterior angle of this. And again, I would just solve it as normal. I would combine like terms over here and simplify it, and then start moving things to whatever side you need to get x by itself. So hopefully that has helped. If you have any questions, please feel free to email me. I apologize for getting this out so late. I also apologize for this being long, but hopefully this helps out.